Very warm welcome to the course Elements of Mechanical Engineering. Myself, Atchuta Ramacharyulu. I am working as an assistant professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering College. So, in today's topic, we are going to discuss open loop and closed loop systems. So, the topic is open loop and closed loop systems. So, as a part of automation, we have studied the automation processes in the previous lecture. So in this class, we are going to see open loop and closed loop systems. So let us see what is an open loop system. Open loop system is a control system that operates without feedback loop. So I have a system which do a process. If I does not have a feedback system, which means this process will have input and this process will also have some output. So both input and output are very important for any process to be done as we are studying the manufacturing machines or manufacturing processes. We will discuss about the computer numerical control systems. So here the process itself indicates manufacturing process. Manufacturing processes like building, machining, turning, drilling, etc. So any process will have an input. Any process will have an input. So after the process has been completed, we will get some output. For example, if we take a drilling process. In drilling process, we will give the workpiece and with the help of a drilling machine, we will make the hole in the workpiece. Okay. So here the input is workpiece without hole. The process is drilling process and the output is the workpiece with a hole obtained. So during the process, the drilling machine will work and it will make a hole in the workpiece. So here the input is blank workpiece, output is a workpiece with a central hole. Now, if there is no feedback, the feedback is not there, what happens? The process system, the manufacturing system which do the process does not know how the output is. It does not care about the output. Only it will make the drilling and it will leave the workpiece. So, in open loop system, there is no feedback system. Okay. The input is not affected by the output variable. So, this is open loop system where the end product is not taken as feedback into the input of the process system. Okay. Now, if there is a closed loop system, which means there is a feedback. What this feedback system will do is, it will take the output and this output is analyzed and it is sent back to the input. Okay. Now, the output parameters or variables are now processed and sent back to the input system so that in the next step of the process or in the next stage, what happens is this input combined with the feedback is given to the process system. Then the next step or repeated step is modified according to the need. If there is no need to modify, there will be no changes in the process. Okay. Now we'll see different points related to open loop system. So this is the slide about open loop system. So the first point is open loop control system operates without the feedback loop. There is no feedback system in open loop. And then second point is, in this the control works without the measuring of the output variables. So the output variables which are generated from the manufacturing system at the end will not be measured or will not be studied. Okay. So in open loop system, the outputs are not cared about. And third point is in this, the control relies on accurate model. So without considering the output of the system. How does the system works? It works on a accurate model. We should know what is an accurate model. Accurate model means the model which is predefined to the system. Suppose if I have a lathe machine. So for lathe machine, I will give one input as to turn the object into 50 mm diameter. Now I have taken a object which is more than 50 mm diameter, which is a cylindrical rod. I have inserted this cylindrical rod into the lathe machine and I have started working. So what input I will give is, I will give the input to turning operation to decrease the diameter of the cylindrical rod to a diameter of 50 mm. So here, what the machine will do? The machine simply, without caring about the output, it will simply take the 50 mm diameter as input and it will process, or it will turn the workpiece into this required diameter, and then after that it will leave. The workpiece will be left over. So this is accurate model. Accurate model means a predefined set of model which is given to the system before the beginning of the process. Okay. So in this, the controller completely relies on the accurate model. There is no closed system. I mean, there is no feedback here. That is why it depends on a standard accurate model. So here accurate model is called as standard model. Now, so the next point is, in this system, that means open system, the actuator may not have the intended effect on the process. Now we should know what is an actuator. What is an actuator? An actuator is a machine which is operated by a control system. We should have a control system here. This control system will operate the actuator. What is an actuator will do? It can create some motion. So before understanding the actuator, we should study what is the actual function of a actuator. So what is the function of an actuator? It can create motion in any form. Like there are basically two types of motions are there. First one is linear motion. Second one is rotary motion. Okay. So the linear motion or rotary motions can be generated by an actuator. Okay. So the actuator can create motion. So this actuator could be any device like a electric motor, or a pneumatic cylinder, or any kind of a machine which can create motion. Now, this actuator is being controlled by the control system. What is a control system? We have studied in the previous class. The control system is the one which controls the machine with the help of a numerical control or with the help of a computer. So this control system will control the actuator. Now, in open system, what happens is the controller relies on in this system, the actuator may not have intended effect on the process. What happens is, in an open loop system, the actuator will not have intended effect. That means, if I have an actuator in the process, it has to move the object from point A to point B. Now, this actuator will not have the required effect on the process because there is no feedback system. That means I don't know how the output is. I know the input values because they are predefined, but I don't know how the output end product is. Without knowing the end product parameters, we cannot give this feedback to the input so that the actuator will not change according to the requirement. Here there is no feedback system, there is no control over the actuator. The actuator cannot affect the process. And then the last point is, the advantage of this system is simple and less expensive than the closed loop system. So there is only one advantage of the open loop system. Only one advantage. This is simple and less expensive. This process is simple and less expensive. So this is the only advantage of the open loop system, where we can get maximum systems with when we want to build a system at low price, we have to use open loop system. So what we are studying? We are studying the automation of mechanical manufacturing processes instruments. In this, we are using open loop systems. Now this open loop is attached to the manufacturing process. Now this manufacturing process machine will cost lower than the system which has a closed loop. Now this open loop is very less expensive and it is simple. Now let us study some basic properties of an open loop system. Now open loop system is appropriate when the actions performed by the control system are simple. So when do we prefer a open loop system? The actions performed by the control system are simple. Then only we can prefer an open loop system, because open loop system does not care about the output input correlation. There is no connection between output and input. That is why when the actions are very simple, that means if I use a manufacturing system or a manufacturing process for a very simple steps, then we can choose open loop system, or else we should go for closed loop system. Okay. Now the second thing is the actuating function is very reliable. We have seen what is an actuator. Actuator is a machine which can create motion. Now if the actuator motion is very reliable, then there is no need for closed loop system. We can simply rely on the open loop, because there is no need to worry about the output or the motion of the actuator during the process. Okay. So if there are multiple actuators present in the manufacturing process or manufacturing system, then we should go for closed loop system. Okay. If the single actuator is present in the system, there is no need for closed loop. We can simply go for open loop. And then third point is, any reaction forces opposing the actuation are small enough to have no effect on the actuation. So here we are seeing about reaction forces. Any reaction force opposing the actuation are small. So we have an actuator. It can create some motion. It can create linear or rotatory motions. So if these motions are opposed by any reactive forces, like any stoppages are there, if I keep a object on the machine, if it is rotating, if some obstacle has stopped the motion of the object, rotating motion of the object, then we should have a closed loop feedback system to know that the object has been stopped. If there is no possibility of obstacles, then we can go for open loop system. If I have a system very simple and it does not have any obstacles for smooth operation, then we can go for open loop system. If there are no reactive forces opposing the machine, then it is very reliable to use open loop system. Now here we'll see, here the flowchart is there. In this we can clearly see, we will have an input parameter, we will have a controller, we will have an actuator, a process and output variable. So these are the key components of any open loop system. Okay, we are studying the open loop system. These are the key components. First of all, we need a controller. This is the controller which controls the entire system. So what does the controller do? It will take the input from external source or a computer. It will take the input from external source. It will process the information into the required form or required code. Then this signal or code will be sent to the actuator. Now the actuator will work. Okay. First the controller will take the input. This input is converted into some kind of signal, and this signal is sent to the actuator. What the actuator will do? Actuator will make the create the rotary or linear motion. Now this actuator will generate some kind of process. Actuator, with the help of signals from the controller, it can generate some motion. This motion will result in a process. Okay, and then after the process has been completed, we will get some outputs. So here, input parameter and output variables are there. Okay, so this is the open loop system where the output variable and input parameters are not connected. These two are not connected. So whatever the output is, we don't rely on the output information, because we consider that this process will be a, what we call, in the previous slide we have seen, we can simply say this is an accurate model. Okay, so this accurate model, there is no need to interact the output variables with input parameter, because we consider that this is an accurate model and it is said to be done as accurate as given inputs. Okay, so that is why there is no feedback system here, and only the required systems are controller, actuator and process. Okay, these three systems are required in order to control a system, in order to complete a process. Okay, now here one important point is there. The input parameter which is given to the controller, the controller is a device which will control the entire system. The actuator is the device which can create motion, and the process is the device where the actual process is done. Now we will finally get an output variable. Now let us take an example of this open loop system. Now if I have a system like I can take the example of a lathe machine. In lathe machine, we can do machining operation with the help of a tool which is made up of a hard alloy. Now this tool can be fixed on the tool post. The workpiece is fixed in the chuck of the lathe machine. Now when the lathe is turned on, the chuck will be rotating at a speed of like 50 rpm or 100 rpm. Whenever the machine is turning, I mean the chuck is rotating, we will take the tool post along with the tool near to the workpiece. What happens is this workpiece is cut, or the material from the workpiece is removed by the cutting tool. Okay, so the cutting tool will remove required amount of material from the workpiece. This entire thing should be controlled by a skilled human being. Okay, here when a human is doing this operation, that means turning a rod on the lathe machine, the human being is the key factor, and he will act as the feedback system, because he will observe the output so that he will change the input. Whatever the output is there, he will react to this output and he will change the input accordingly. Okay, now this is all about open loop system. Now we'll go to the next topic, that is closed loop system. Now let us see what is a closed loop system. In this diagram we can see clearly, here we have the same thing. Controller is there, actuator is there, process is there. We have some input parameters and we have some output variables. Now the only thing present here is feedback sensor. Now see here, the feedback sensor is the key which will give the output variables. It will collect the output variables and it will process the variables, and this processed information will be sent back to the controller. So what does the controller do? The controller will analyze the information from the output variables, and it will convert that information along with the input parameters, and it will change the process or change the motion of the actuator accordingly. So that is the function of the controller. Okay. Now in the system, the output variable is compared with the input parameters, and the difference between these two is used to drive the output into agreement with the input. Now what we are saying is, in a closed loop system, The feedback is attached between the output and controller. So whatever the output has been happened, those results will be taken back to the feedback sensors or feedback system, and these data is processed in the feedback system, and this information will be given back to the controller. Now in the controller, what happens is this information is analyzed, and the input parameters are also joined with the feedback information, and entire thing will be done in the processing of the information both from the feedback and input will be done by the controller, and this information is converted into signal, and again it is sent to the actuator for doing the required process. Okay, so what happens is in closed loop system, the input parameters and output variables, the difference between these two is analyzed, and this information is used with the output into, in the next input cycle we will give this as the input. Okay, so this is a closed loop system. So the best example for closed loop system is here we have so first of all we'll see the basic elements of any closed loop system. First one is these are the basic elements: input, controller, actuator, process, and output variable, feedback sensor. These are the 6 basic components of any closed loop system, starting from input, controller, actuator, process, output variable, and feedback sensor. And then we'll see the input parameter is referred as set point, represents the desired value of output. Now see here, this is a very important point regarding the closed loop system. Here the input parameter, whatever the parameter is given as the input to the controller. So this is set as set point. This is called as set point, represents the desired value of the output. So the input value will decides the output parameter. Depending on the input only, the output will change. Now this process is also called as a feedback control system. The second point is feedback control system. Closed loop system is also called as feedback control system because a feedback sensor or feedback device is used to analyze the output and send that information to the input. Now here we have an example. In homes we have home temperature control systems. Simply we can say this is an AC. What AC stands for air conditioner. So what does the AC will do? AC will, a full form of AC is air conditioning. Air conditioning means it will condition the air which is present in the room. That means it will suck the air from the room inside and it will send it to the compressor. There the air gets cooled and this air is again sent back into the room. Okay. So what is the key function of an AC? If I set the temperature of an air conditioning system at 24 degrees centigrade, what it will do is, it will try to cool the room up to 24 degrees centigrade. Okay. So what it will do, so this is the AC system. Here this is the input and this is output. Now we have seen in the closed loop system, there will be input and output, and in between there will be some process. See, here the AC is the machine which will cool the air. Its function is to cool the air and it will send the air back into the room. Now here the input is whatever the hot gases, hot air present in the room is sucked into the air conditioning system, and this air conditioning system along with the help of compressor, it will cool the air. Whenever the air flows into the air conditioning system, the air will get cooled. The hot gases, hot temperature of the air will be removed and it will be sent to the outer system which is present in the split AC model. The heat is removed with the help of a compressor. Now the cool air which is coming out of the air conditioning vent, this will be sent into the room. Now here input is the hot air. Hot air is the input. Output is cold air. Now, if I don't have a feedback system. That means if I don't know how the cold air temperature is, then what I will do is I will keep on cooling the air. I will continuously blow the air into the room. The room will get more and more cooler, which is not required for a human being who is staying in the room, because if the temperatures are below required room or the room temperatures, we will feel some discomfort and we will feel very cold. Now, I will arrange a feedback system. I will arrange a feedback system. What this feedback system will do is, it will measure the temperature of the cold air which is sent into the room. Now, this cold air temperature is around 24 degrees centigrade. I will inform the same information to the controller. Okay, now the temperature of the air inside the room is around 24 degrees centigrade. I will use a sensor for that information, that is called thermostat. Okay, now this thermostat will sense the temperature of the room, air room. Now this, whenever the temperature is reached the required value, this thermostat will send the information to the controller that the temperature is around 24 degrees. There is no need for further cooling. So what happens is, this AC machine will turn off. Whenever the temperature reaches 24 degrees centigrade, the feedback is given to the controller and this controller will switch off the AC machine. Okay. Now, AC machine, what it will do is, after some time, when the temperature is 24 degrees centigrade, it will turn off, and after some time, what happens is the room temperature will slightly increases. If it increases to 25 degrees centigrade, what happens? Again, the thermostat is the sensor. This thermostat will sense the temperature of the room and it states that the temperature of the room is 25 degrees centigrade, but the given value is 24 degrees centigrade because it is more than the required temperature. So again, it will turn on the AC machine so as to cool the room. Okay, so this is the best example for a closed loop system where we will use a thermostat for measuring the temperature of the room and work the room temperature system or the air conditioning system accordingly. Okay, so here the thermostat is a device which is based on the thermal property. It will sense the temperature. When the temperature is above the required level, it will send some signal to the controller. The controller will increase or decrease the working process of the air conditioning system. So this is how the closed loop system will work. And so we have completed with the open loop and closed loop systems. Now we will see how advanced manufacturing systems will work. Here we have advanced automation functions. So what are the advanced features of any automated system? We have some systems like CNC or numerical control, NC machines, and then robots. So these are some of the automations given to the manufacturing systems, because we are studying a subject related to mechanical engineering where we will study about manufacturing processes and machining processes. We use computer numerical control or robots for doing the manufacturing processes, different manufacturing processes. Now, what are the advanced automations these machines can do? We'll see. The first one is safety monitoring. So the first thing we have seen in the last class that the automation was first used by an automobile company called Ford. Nowadays, these Ford cars are still in use. So this Ford company back in the year 1950 or 1960s, it tried to introduce the automation to all the manufacturing processes in the manufacturing of its cars. Ford. So in that, one best feature of automation is safety monitoring. See here, one of the significant reasons why the automation is introduced into the manufacturing processes system is it can avoid hazardous working environments to the workers. If I am working in a place where some hazardous environment is there, then this advanced automation system will let me know that this process or this environment is very dangerous for human beings. That is why you are not allowed to work in this place. Simply, instead of human being, this machine will work. See here. Safety monitoring to avoid hazardous working environment. Suppose I will take the example of painting a car body. Painting a car body. If I have a car, I have manufactured the body or frame of the car, I have to paint it with the help of a jet spray. Now, what happens is, what is the risk for human beings in painting the car? Now, normal painting is very simple and it is more conventional and it will take more time. Instead of conventional painting with hand and brush, we will use some spray jet painting kind of machine in car manufacturing systems. So, here the painting will be done with the help of a jet spray where we use compressed air. This compressed air will blow the paint into the nozzle and this nozzle can be placed anywhere to paint the body. Okay. Now, if I take the painting of the car, because we are using a nozzle and compressed air, the paint will be coming out of the nozzle at a very high speed and very fine particles of the paint will be coming out. So, what happens is, these fine particles of the paint can enter into human nose or eyes, okay, and they can cause severe damage to human health. That is why painting with the help of a spray paint is very hazardous environment where human beings are not allowed to work. That is why we have replaced human beings with the robots. We will use industrial robots, where the painting job will be done by these robots, and we have replaced the human beings because the painting is no longer a safety process for human beings. Okay. Now, along with this is one of the example of safety monitoring system. That means we can use the automation for painting and other operations are there where high speed and high precision is required. Using the industrial robots for painting, they can paint at a faster rate when compared to human beings. That is another advantage of using advanced automation function. And then, so safety monitoring, we have 4 points. Complete stoppage of the system. Suppose if the system has failed, if I have a big manufacturing unit and in that human beings are working at different places, at different machines. Like if any damage or if any accident happened, immediately the system will be shut down. Complete stoppage of the system will be done so that the further accident, the further bad things should not happen. And the second one is sounding an alarm. If any malfunction or an accident happens in a system, in a manufacturing system, sounding alarm is also done by the automation. Okay, so no need for a human being to on the alarm by himself. This alarm should be blown on its own. Okay, and then third point is reducing the operation speed of the process. Okay, whenever there is a malfunction in the system, if the malfunction is detected by the automation, what it will do is it will reduce the operating speed of the process. Whenever some machines will be there which will be rotating at higher speeds like 1000-2000 RPMs. Now, if there is any malfunction in the machine, the entire system is not stopped, but the speed is reduced so that the accidental severity should be reduced. And the last point is taking corrective actions to recover from the safety violations. This is one best thing of the advanced automations, where corrective action will be taken by the automation machine itself. Suppose if I have a machine, this machine is automated. Now what it will do is, I have found some malfunction in the system. this automation, what it will do is, it will automatically recover the system from that malfunction. It will repair on its own. Okay, so this is best function of the automated systems. Okay, there are some other points where we have to discuss. The next slide: maintenance and repair diagnostics. So in maintenance and repair diagnostics, this automation is very helpful. Okay, there are modern automated production systems are complex and sophisticated. Thus, the need of maintenance and repair diagnostics are must in their design. So nowadays the systems are very complex and they can do multiple things at a single time, and they will have multiple units working in a smaller place, yet they are complex. So if the machine get any repair, we as a human beings, it is very hard to find where the malfunction has happened or damage has happened in the system. So because there are multiple units working together for doing a process, so whenever the system is complex, to find the damage or any mistake, so it is very hard to find the malfunction. So that is why the automation systems will help to find the damage, and it will send that report to the central processing unit, which is CPU. Okay, so whenever the machines need maintenance, so not only the repair diagnostics, it should send the maintenance diagnostics also. Okay, repair means whenever the object is malfunctioned or it is damaged, then we have to do repair. But maintenance is precautionary. What happens in maintenance is, before the malfunction or before the damage of the system, we should sense the damage, and this report should be sent to the central processing unit. So both these repair and maintenance diagnostics can be sent to the system with the help of automation. So these are some of the advanced automation features. Now see here, three modes of operations are typical in the system. First one is status monitoring. Status monitoring means how the system is working. We should know how the system is working, whether the system is working at the rated RPM or not, whether it is working as per the instructions given by the user or not. So these are the status monitoring reports. This is given by the system. And then second one is failure diagnostics. Whenever there is a failure in the system, that report should be sent to the central processing module, where this required action will be taken. And then third one is recommendations of repair procedures. So some advanced manufacturing systems will give the recommendations also. Okay, so if I take the photocopy machine, now here I will take an example of photocopy machine. This photocopy machine generally we use in the most other places. What it will do is, it will simply print the pages. Sometimes they are used for scanning also. So what they will do is, not only printing and scanning, they will inform you about whenever the cartridge is empty. It will inform you before only. The cartridge is about to empty, so please replace the cartridge with a new one. So these are some of the recommendations. Or sometimes it will show that the scanning glass should be cleaned. The scanning glass inside the scanner should be cleaned in order to get a better scanning of the documents. So these are some of the examples of recommendation of repair procedures. So the system itself will recommend the repairs, what kind of repairs should be done, or what kind of errors has happened in the system. So these are some of the recommendations given by the advanced automation system. Now next one is, this is another feature of the advanced automation system, error detection and recovery. So in the operation of any automated system, there are hardware malfunctions and unexpected events that occur during operation. So there are some malfunctioning will be there are some damages will be there, accidents will be occurring in the machines. So these machines should be detected, these errors should be detected by the system. Okay, not only detection of the errors, they should be recovered also. Okay, so the advanced manufacturing systems are developed in such a way that they are not only detecting the errors there, but they are also recover the errors from the systems. So these events can result in costly delays and loss of production until the problem has been corrected and regular operations is restored. So what happens is, whenever there is a damage or malfunctioning of the system, what happens is they will make the systems does not work on time, and they will stop the system working fine. So that is why these systems should be detected for errors, and they should be recovered. Okay, so while recovering from the errors, uh, if the human beings try to identify these problems, identify the damages or malfunctions of the system, it will take more time. So that is why we are using automation. In the place of human being, we will use automation, and these automated machines will detect the error where the malfunction or the damage has happened, and it will give the feedback to the human being or worker who is working at there. And then second point is our third point. Generally, human workers will take the action against the malfunctions. Okay, so whenever there a system is damaged or some part of the manufacturing system is malfunctioning, so what happens is the input or the feedback from the automation system is given to the computer where the human beings will be working. This human worker will take care of the malfunction. Okay, so human being will go there and to make the repairs for the machine. Okay, now this is what happens in the conventional system. In the olden days, human beings will see whether which part of the machine is damaged, and he has to replace that object, or he has to repair, he has to replace the object. Okay, this is all done by manually. Now, with the increase in the use of computers, control machines, not only diagnostics but the recovery action is also done by the computers. So, the recovery, first thing is diagnosis. Diagnosis means whether the system is damaged or not will be diagnosed with the help of a computer. Now, this computer will give the information about the damage of the system. Now, a human being will come there and he will replace or repair the object in order to make the system working properly. Now, with the advanced systems in the advancement in the systems, what happens is this recovery is also done by the computer itself. Like I have said in the previous slide, that one example about the photocopy machine, it will alert you. It will alert you about the malfunctioning of the system. Then we have to go and we have to make the required repairs. Now, advanced systems are such a way that it can repair itself or it can replace itself with a new product so that it can work on its own. Okay, so this is the advanced property of the automation system. And the last one is the term error detection and recovery is used when computer is used for recovery of the malfunction. See, error detection is there. What is the meaning of the error detection is, this term is used when the computer itself is used for repairing the machine. Computer itself will diagnose and it will know how to repair the required error in order to make the system work properly. Okay, so these are some of the important points of automated systems, where we can use the automated system for advanced options. Like we have seen, first one is safety monitoring, and second one is maintenance and repair diagnostics, and third one is error detection. So in this class, we have seen about open loop and closed loop systems, where open loop systems are where there is no feedback is taken from the output, and closed loop systems are where the systems will take the feedback information with the help of feedback sensors or feedback machines. And then we have studied about advanced automation systems, where we will study the error detection, maintenance, and safety monitoring. So these are all the options advantages of the advanced automation system. Now, in the next class, we will see how a CNC machine will work. What are the components of a CNC machine? What are the key components of a CNC machine? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.